Hello everyone. Today we will learn principal component regression. As you can see here, we have added some libraries like Panda, NumPy, Matplot library, and sklearn library. To read CSV file, we have used pd.read underscore CSV, and here we have used drop na method. So it will remove all the missing values. After that, dataframe.info. It will print a concise summary of data frame, and at the end we will get this as output. Let's perform some exercise. First one is create dummy variable from categorical variables. To convert categorical variable into dummy variables, we have used panda.getDummies. Here data frame df and drop underscore first is equal to true. So it will remove first column and print the rest of the data. And here data frame dot head. So basically it will print first 5 line as output, as you can see. Now second one, define y as salary and x as all other variables including dummies. To define y as salary, we have performed this operation, and after that we have dropped salary. So syntax x is equal to tf dot drop salary, and axis is equal to 1. Here we have used axis is equal to 1. So basically it doesn't know what is the salary mean, whether it is index or column. So to indicate, we are removing column. So if we had indicated axis is equal to 0, then it would have believed salary as index. After that, x dot shape. So here we have print shape of array. So at the end we will get this as output. Now third one, split the data into train and test datasets. Run a principal component analysis on the scaled training data with the maximum number of components. To split the data, we will use scikit-learn library that we have added over here, sklearn as model selection. There is one method called train test split in model selection library. Basically, this method will split array or matrix into random, train, and test subsets. And and here we have used random state is equal to 10. So the random state parameter is used to initialize the internal random number generator, which will decide the splitting of data into train and test. Indicates in our case, setting random state a fixed value will guarantee that the same sequence of a random number is guaranteed each time we run the code. Here xtrain is all the instance with attributes, and ytrain is the label of each instance. To perform principal component analysis on xtrain, we used scale method and performed fit transform on it. But here we have not mentioned n components, or we can say we have not set n components, so it will keep all the components and perform principal component analysis on it and store it into xpca train. Again xpca train dot shape, so it will return the array shape. Now fourth one, plot MSE using fivefold cross validation corresponding to each number of principal component. 1 to the maximum number of principal components. What is the number of principal components that minimize the MSE? Uh, First one, linear regression. After that, second one is model selection dot k fold and splits is equal to 5. So here k fold is a cross validator, and it splits dataset into k consecutive folds, and there is three parameters: n splits, shuffle, and random state. Here we use n splits, the number of folds that we want to divide into, here 5. The default value is 5, so if we don't write anything over here, then it will take 5 as by default. Here we have taken empty MSE. After that, for loop for all I in np.arrange 1 to 10. So basically, numpy arrange will return evenly spaced values within a given interval. Model selection cross validation score. So basically, it will evaluate a score by cross validation, and there are 5 parameters of cross validation score. The first one, M, it is estimator, the object to use to fit the data. Here here is M, and after that, X, the data to fit. Understand the difference between these two things. M, the estimator, the object to use to feed the data, and the X, the data to fit. List or an array can be the example of X. The meaning of this thing is all the row and till ith column. So it will take all the rows and till ith column data. After that, Y, the target variable to try to predict in the case of supervised learning. And then group, basically it is a CV instance, and it is used as a group while we are splitting the data. And then scoring, basically it is similar to cross validate, but only a single metric is permitted. If it's if it's none, then the estimator's default score is used. After that, the mean of all these things. At the end, we will append the score to the MSE that we have defined over here. To draw the diagram, we have used matplot library, and there is a plot method in it, and we used MSE to draw the diagram, and marker is O, X label is number of principal components in regression, and Y label is MSE. So we will get this as output. The fifth one, calculate MSE from the OLS with the optimal number of principal components on the test data. To run principal component analysis on test data, we have performed this line, and at the end, xpc test dot shape. So we will get this as output. To keep all the row and all 5 columns, we have performed this operation, and to print we have used this operation xpc test dot shape. So at the end we will get this output. Fit method, basically it will take the training data as argument, the first array, x principal component train, all row till fifth column, and y training data, and we will perform linear regression on it and store it into m1. After that we used predict method. Basically it returns the labels of the data passed as an argument based upon the learned or trained data obtained from the model. Thus, the predict function works on the top of trained model and makes us of the learned label to map and predict the labels for the data to be tested. So here we have performed predict on x principal component test and stored into predict 1, and then mean squared error. So it's basically mean squared error regression loss. So at the end we will get this as output. The sixth one, calculate MSE from the ordinary least squares with the original predictors on the test data. Again, linear regression, fit X train and Y train. Uh, we have stored this linear regression in M2. Again, we have performed predict on X test and stored into predict 2. MSE, mean squared error, Y test and predict 2. And at the end, we got this as output. And at the end, difference of both MSC divided by MSC1. So we got this as output. That's it for today. Thank you.